Cadence provides IP solutions across all major standards with unsurpassed reliability to help accelerate our customers' time to market. I'm John Tam, Product Marketing Group Director, and I'm here with Lavith in our Bangalore labs. He's the Design Engineering Group Director in charge of product validation. Lavith, tell us what you're going to show us today.
Thanks, John. At Cadence, we not only build IP, but we build test vehicles that enable us to comprehensively verify our solutions against the latest commercially available solutions in the market. Let's look at the demonstration that we have set up today. Here we have an ASUS motherboard that is PCIe 5.0 compliant, and it is connected to a Broadcom Atlas 3 switch, which is PCIe 6.0 compliant. On the other end of the switch, we have 5 different Cadence PCIe endpoints. So as you can see, we have a representation of a real-world system where we have a motherboard talking to several different endpoints through a switch. Let us now initialize the entire system. As you can see, all the endpoints have successfully linked up. So we have a Niagara N5 with a Gen 6x8 link, a Niagara N5 in E3.S form factor with a Gen 6x4 link. Then we have a Piper N3 with a Gen 6x1 link. We have a Niagara 3 nanometer with a Gen 6x8 link. And finally, a Whistler in 3 nanometer with a Gen 5x8 link.
Lavith, that is great. What do customers care about electrical performance?
There are several important electrical parameters that the customer care about. The primary among them being the receiver margin. Let's look at the receiver margin on one of the PCIe 6.0 links here. The Cadence PCIe 6.05 has several built-in functions to evaluate the receiver margin. On the left, we see a non-destructive eye plot, which clearly shows a good linear eye. On the right, we see the histogram of the data at the output of the DSP, which clearly shows 4 different PAM4 levels with good margin between them. This is one of the tools that we use to evaluate the margin on the receiver, which is the critical parameter in ensuring the link's robustness.
So Lavith, real deployments need to be robust with changing links and changing states all the time. So how do we test for that?
Because we build our test vehicles with the entire protocol stack, it gives us the ability to emulate several of these real-life situations where we can perform rigorous system stress testing with commercially available latest platforms. Let's look at some of the such use cases now. I will run a link-enable-disable test on one of the Gen 6.0 by 8 links. In our regular product validation, we run these cycles for millions of times to make sure our product is healthy and robust. So as you can see here, the system is going through several cycles of link-enable-disable system. And you can see the different transitions of the PCIe FSM, ltssm here. Having the ability to perform such tests with the Cadence test vehicles is a clear differentiator. And this is what really enables us to be market leaders in the PCIe segment. As you see here, we've just successfully completed 100 iterations of the link-enable-disable test. Let's now look at another use case, which is the hot reset test. As you see, the hot reset test has also passed successfully. Another common use mode is the low power entry and exit. Cadence offers a very competitive solution when it comes to lower power.
Thanks, Lavith, for showing us a real-time demo. Really shows and it will demonstrate Cadence IP solution for AI. For more information, you can find that on www.cadence.com.